a ruler and how to decide how many decimal places to write down. So here was a ruler from the last time, and we can see if we're looking at this side of the ruler, we're going 10, 20, 30. We have the tens place, so we would guess the ones place. That means if we had this block of wood, and we'd still have the parallax error over there, but if we try to look straight down here, we'd see that's maybe 17 centimeters plus or minus. Then we had a better ruler, and we saw, oh look, our guess wasn't bad. It's a little bit more than 17, and we got to see more Sig Figs and more decimal places. So, why the big deal? Well, the number of significant figures, or the uncertainty, are going to determine where you round off every time you use your calculator in this class. So, we have to really understand every time we look at a number, how many Sig Figs, or what the uncertainty is. That's pretty easy if you have a ruler in front of you. So what if you have something like this? Let's say you look at this and you say, oh, I think that's about 17.3. So you write down, 17.3 centimeters and plus or minus. Well, that 0.3 was a guess, so I'll say I could be off by 1/10 of a centimeter with this ruler. If I turn the block this way, now it looks like it's maybe 9.5. And something different happens. Centimeters. Because this ruler still goes by ones, I'm still going to guess the tenths place. No big deal. But even though the uncertainty did not change, the number of Sig Figs did. This one has 3 significant figures, and this one only has 2 significant figures. Why? Well, couldn't we pretend that we measured the tens place here and there was a 0 in that value? Well, that's kind of dumb. We could do that forever. So we kind of don't start counting Sig Figs until we get to a number going this way that's not 0. So the first digit we get to here is the tens place, then the ones and the tenths. In this one, our first place we get to is the ones place. So that's why the top number would have 3 Sig Figs, which I just said there, and the next one would have 2 Sig Figs. Let's look at this case and another example. Let's say we had this other ruler. Okay. It's a strange looking ruler. Yes, it's a bit homemade. But you know what? Rulers in the truest sense are all homemade. And I don't know what this unit is. It looks like OX, whatever that means. But it looks like that line there is 0.01 or 1/100th of an ox, whatever that length unit is. That means if I measure the block using this ruler, let's see, 0.01, that's 0.02. So I would be guessing, let's see, oh no, I wouldn't be guessing because I know the next digit down. So I'm certain that I know the 100th digit, and I'm certain I know the next digit. Now those aren't the right numbers, but those are the digits I would know. Then I could guess. So this ruler looks like it's going to have a 100th place, a 1,000th place, and I will guess the 10,000th place. So this ruler is plus or minus a 10,000th of an ox. So if I put that here and I say, okay, I think that's about 0.01, see 1, 2, 3, 4, 5, 6, 7, 0.017 and a little bit past, maybe I'll go 3 ox plus or minus 0.001, oops, 1, 2, 3, 4, 0.01 ox. That's the uncertainty, is how far off my guess might be. It must plus or minus 1 in that last decimal place. How many Sig Figs is that though? Well, this 0 here is now confusing because at this point on the ruler, I haven't even gotten to the 10th place. That would occur way over there somewhere. So if we use the same logic we did a second ago, I shouldn't start counting significant figures until I get to a number that is using the ruler. So I'll say this is my first Sig Fig, that's my second, and that's my third, and I'll say this number has 3 significant figures. That means this 0 doesn't count. The 0 like that is holding the 1 out in the 100th place. That 0 is called a decimal placeholder, but it's not a significant figure. you can see that the zeros are going to be confusing. If I look at the block this way, okay, now it looks like it's point, let's see, 0.01, so that's 0.001, 002, 003, maybe 0.003, I don't know, 7 ox, plus or minus 0.1231 ox. So look at this measurement for the width of this block. It looks like we're still plus or minus tenths, hundreds, thousands, 10 thousandths, but the measurement itself doesn't have any value in the tenth place or hundredth place. I haven't made it to the hundredth part of the ruler yet. I'm way down here. So the first significant figure would be the 3, and the next one would be the 7. This would be 2 sig figs. So the uncertainty doesn't change, but the number of significant figures can change. Imagine this situation. Let's just make a fake ruler and say, what if you had, a ruler that started here at 0 and went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 2, and that was like 100. I don't know. Let's pretend we're zoomed way out, and that's 100 centimeters. Well, what would I write if that was my measurement? Well, let's see. I know the hundreds place, because that's this one. I know the tens place, that's this one. So I would guess the ones place. So 10, 20, 30, 40, 50, 60, 70, I'll call it 75 centimeters plus or minus 1 centimeter, because that's where I guessed. That would be 2 sig figs. Likewise, if the thing I was measuring was way down here, it'd be, well, I didn't make it to the ones place. Sorry, I didn't make it to the tens place, because these are worth 10 each. You have to make it to the ones place, because that's what the uncertainty is. So that looks like it's about, I don't know, 7 centimeters, plus or minus 1 centimeter, but only 1 sig fig. Well, things get strange if it's right on the line. Let's say I was measuring something, and I thought it lined up perfectly. Okay? So, this ruler is still plus or minus 1 centimeter, but that looks like it's right on the 100. So I'll write 100 centimeters, and I could say plus or minus 1 centimeter. How many sig figs is that? Well, I measured the hundreds place, I measured the tenths place, and I had 100 and no tenths, and I guessed the ones place because I think it's right on the line. That would be 3 significant figures. But that would be weird if I couldn't see the ruler. In fact, let's look at another situation that's very similar. Let's say that was 100, 200, 300, 400, 500, 600, 700, 800, 900, and 1,000. 1,000 of some unit. And I thought the thing I was measuring was this long. Well, it looks like it's 100. We'll see. We'll just call those units, because I'm not sure what the unit is on this scale. Well, if it's right on the line, then I would say it's 100 units plus or minus whatever place I'm guessing. Well, if the hundreds place is the last one I know, for sure, I must be guessing the tens place. Okay, now that's weird. I'll write plus or minus 10 units. But how many sig figs is that? Well, I measured the hundreds place, and I guessed the tens place. But that 0 wasn't measured. It's just there to make sure we know that the 1 is in the hundreds place. This final 0 is a decimal placeholder. It's holding the decimal place out there. So this is also 2 sig figs, but boy, the zeros can get confusing. So here's a situation where I had 100 plus or minus 1 centimeter and 100 plus or minus 10. But if I didn't see the uncertainty, and I didn't see the ruler, and I just looked at those 2 measurements, I could not tell that this 100, just by looking at it, was plus or minus 1, and therefore 3 significant figures. Or I couldn't tell this one was plus or minus 10. So the zeros can be confusing. So let's summarize how the zeros work. If you have a number, if you see the ruler, you're supposed to be able to figure out how all of these work. But if you don't see the ruler and you just see a number on a piece of paper, if the number looks like this, 1.4 centimeters, well, clearly the ones place and the tens place, that's 2 sig figs, and I'll assume the 4 must have been guessed, so I'll say plus or minus 0.1 centimeters as the uncertainty. If I said 1.40 centimeters, okay, well, why is that 0 there? The author must be trying to tell me, because a math teacher would not put that 0 there, the author must be trying to tell me that 0 was actually measured, or at least guessed. So I would say 1, 2, 3 sig figs, and I would assume that that 0 is telling me it's plus or minus 0.01 centimeters. If I had a number like this, 104 centimeters, well, that 0 is not a problem. You can't measure the hundreds place and the ones place and never look at the tens place. So that's 3 sig figs, and I'll assume plus or minus 1 centimeter. So I've got a 0 that's called a trailing 0. They count. It's a terrible spelling of the word trailing. And I've got a trapped 0. They count. The next example would be something like this, 0.012 centimeters. Well, in that example, that 0 is holding the 1 out in the hundredths place, but I did not get to that part of the ruler. So I'll say that's 2 sig figs, and plus or minus 1 in that last place, 0.001 centimeters. So in this case, the 0 there is not a significant figure. It's a decimal placeholder. You can even get all of them in one example. 120 centimeters. Now that 0 doesn't count, and that one does. Decimal placeholder, trailing 0. Then our final situation is a number like this, 100 centimeters. If I put plus or minus 1 centimeter, so that was the uncertainty was given, then I know it's 3 sig figs. But if that's not given, then I can't be certain how many significant figures that is, because I don't know the uncertainty without seeing the ruler. This is called the ambiguous case. That ambiguous means not enough information to be sure. So what do? Well, I can't tell. On the test, I would write, I can't tell how many sig figs that is. What if I wanted it to be plus or minus 1? What are my options? Well, I could write 100 centimeters plus or minus 1 centimeter. Now I know it's 3 sig figs. Most schools will let you write this, 100, and just put the decimal point in. And the fact that the decimal point is there when it doesn't need to be is telling you that the ones place counts. That'd be another way to know that's 3 sig figs. At our school, another way would be to say, well, I'll underline the last number and that it was measured. Technically it was guessed, but it counts as measured. And that underline is telling me that there are plus or minus 1 and 3 significant figures. The best way is to write it in scientific notation, because in scientific notation, all of the numbers are significant figures. We'll come back to that. So I'm going to put some examples here, and your homework for tonight is just to write down the examples and how many significant figures in each one. Okay, so here are 1, 2, 3, 4, 5, 6, 7 problems for your homework tonight. And all I want you to do is write down the number of sig figs and the uncertainty that you're assuming each one has. And so for each one, you'll write 2 answers, and tomorrow we'll collect that, and that'll be your homework.